So my dear students, again I am here. Everybody has a big dream. सभी चाहते हैं कि अपने लक्ष्य को प्राप्त करें और आप भी चाहते होंगे। पर मेरे प्यारे बच्चों, अपने लक्ष्य को प्राप्त करने के लिए ज़रूरी है कि हम अपने गुरु, अपने माता पिता, अपने बुजुर्ग लोगों की इज्जत करें। ये बहुत इम्पोर्टेंट होता है। कहते हैं कि पिता एक कड़वे नीम के पेड़ की तरह होता है, जिसकी पत्तियां जरूर कड़वी होती हैं, किंतु उसकी छाया ठंडी होती है और हमारे स्वास्थ्य को हमेशा ठीक रखती हैं। ऑलवेज वी आर हेल्दी इफ वी आर ईटिंग दोज लीव्स, नीम लीव्स। पिता ही संसार में एक ऐसा व्यक्ति होता है बच्चों, जो चाहता है कि उसके बच्चे पिता से भी बड़े बने। तो अपने पिता की बात सुनो, समझो, माता और पिता की इज्जत करो बच्चों। टुडे वी आर गोइंग टू स्टार्ट ए न्यू यूनिट एंड दैट यूनिट इज नोन एज इलेक्ट्रोमैग्नेटिक वेव्स। इलेक्ट्रोमैग्नेटिक waves may be it comprising of only 3 marks, sometimes 4 or 5 also. Nowadays it is of 5 marks in CBSE, but it is very very important to note down the importance of electromagnetic waves in NEET and JEE. On all the examination, these are always asked. These questions are always asked from the electromagnetic waves. तो मैं आपको बताऊंगा कि कौन से questions important हैं, क्या आपको सिर्फ समझना चाहिए। Actually you are now in class 12 and in class 12 we are not only studying for the sake of marks only. Something should be here. We have to learn everything because that is going to be help us throughout our future, in our college life, in as soon as we are or as long as we are going to study. So I am giving you first of all the history of electromagnetic waves. History of electromagnetic waves. Okay? बीच में आपको बताता जाऊंगा मैं कि क्या आपके लिए इम्पोर्टेंट है और क्या इम्पोर्टेंट नहीं है। तो हिस्ट्री आप सिर्फ समझिए, इट इज़ नॉट सो इम्पोर्टेंट एज फार एज द एग्जाम इज कंसर्न। सो look here, first of all, how it starts, electromagnetic waves start हुआ कैसे। So in 1856 Mr. Maxwell, he proposed a theory of symmetry, and according to Mr. Maxwell, if there is a conductor, current carrying conductor, then there is an electric field outside the conductor and also inside the conductor in the space, and that theory leads to the symmetry of electric and magnetic field. In 1874 Maxwell, he predicted the existence of electromagnetic waves, but only theoretically. How theoretically? कैसे बताया भाई theoretically? You know very well, research is very very important in the life or in the science. After research only we are going to know that this thing is really appears or this thing is here, and then उसके बाद हम उसको प्रैक्टिकली बताते हैं, हाँ यार ये तो था। जस्ट लाइक इन फोटो इलेक्ट्रिक इफेक्ट, यू नो वेरी वेल, दे परफॉर्म नंबर ऑफ एक्सपेरिमेंट एंड आफ्टरवर्ड्स दे केम टू नो दैट रियली फोटो इलेक्ट्रिक इफेक्ट इज देयर इन। देन आइंस्टीन गॉट ए नोबेल प्राइज विद मिलिकन्स एंड लेनार्ड। दैट वी आर गोइंग टू डिस्कस आफ्टरवर्ड्स। सो theoretically he proved or predicted the existence of electromagnetic wave using Maxwell's equation 4 Maxwell's equations they were there mathematically. इसीलिए मैं हमेशा कहता हूँ physics is the subject which uses mathematics maximum and mathematics की वजह से ही physics है. So you should know some basic mathematics. मैथमेटिक्स से हम प्रूव कर सकते हैं कि ये चीज़ होगी और है, एंड देन एट लास्ट इट विल कम. आई एम नॉट गोइंग टू टेक योर इनफ टाइम. हम आगे जल्दी जल्दी बढ़ते हैं. तो क्या किया मैक्सवेल ने? एक्चुअली अकॉर्डिंग टू मैक्सवेल, इलेक्ट्रिक फील्ड और इलेक्ट्रिक करंट प्रोड्यूसेस मैग्नेटिक फील्ड, एंड यू नो वेरी वेल देयर इज a symmetry in magnetic and electric field. So according to Maxwell, magnetic field should also be produced by the magnetic field is also going to produce electric field. Again, electric field, time varying electric field can produce a magnetic field, and that time varying magnetic field again produce a time varying electric field, and so a disturbance results in the space, and that disturbance is known as electromagnetic wave. This disturbance propagate in the space. If there is a varying electric field and varying magnetic field, तो varying electric field ने generate किया varying magnetic field, and then that varying magnetic field again generate varying electric field, and then there is a disturbance appears in the space, and that is known as electromagnetic wave. ये इसने प्रूव करके बताया. कैसे पता लगा इसे, कैसे मालूम पड़ा? आगे चलते देखिए. नंबर 2 पे आते हैं. When Maxwell was performing an experiment of charging a capacitor, I am taking a capacitor here. This is a capacitor. These are 2 plates of the capacitor. Okay, plate number 1, plate number 2. This is C1, and it is connecting with a time varying current. Time varying current, time dependent, you know, it means current is changing with respect to the time. And so what happens? Conduction current starts, IC. It charges the plate, and here we will get negative. Are you getting my point? Simple और echo diagram दे रहा हूँ. ये देखिए, these are 2 plates. This is positively charged and this is negatively charged due to time varying current, and that is conduction current. Conduction, कौन सी current? Conduction current. Conduction current, you know very well, it is due to the motion of electrons. It is due to the motion of electrons. Now what happens? What happens here? You know very well, when there is an electric field, there is a magnetic field also. So Maxwell ने वही काम किया. He tried to find the magnetic field here. He tried to find magnetic field here by considering a loop. He considered a loop here. Suppose this is first surface, and this is center O, or maybe P this is. So here he want to find magnetic field. So in order to find magnetic field due to a closed circuit, you know very well, we are using Ampere circuital law. So we are using Ampere circuital law, and from Ampere's circuital law, integration E vector dot dl vector equal to mu naught I. Okay. So he found that here there is a magnetic field, that is mu naught I upon 2 pi r. This is a magnetic field at point P due to this conduction current. And now he considered another loop. Another loop I am taking with different color pen. Suppose I am taking this color, okay. So this color I am taking green one. This is another loop now. Look, this is center now, and suppose this point is Q. This is loop S2. Okay, this is S2 loop. Correct? When we are considering S2 loop, then what happens? Again we are going to discuss with Ampere circuital law, and with Ampere circuital law now, look here, integration B vector dot dl vector equal to mu naught I, but here there is no current in this loop. In this loop there is no current, it is not touching with any conductor. So there is no current. And when there is no current, then what happens? Magnetic field here at point Q is 0. Magnetic field here is 0. This is surprising. Taking one loop, there is a magnetic field, and taking another loop, there is no magnetic field. So this is a contradiction in Ampere circuital law. This is a contradiction in Ampere circuital law. This is a contradiction in Ampere's circuital law. Now, why there is a contradiction in the Ampere circuital law? That's the question. So, according to this, he found there is a new phenomena. He found there is a new phenomena, and what phenomena is there? If there is a time varying current, sorry, this is negative. If there is a time varying current, if there is a time varying current IT, then you know very well there is an electric field appears here, but this electric field is not uniform. It should be not uniform, and if there is no uniform electric field here, then what happens? There is a change in electric flux. There is a change in electric flux, and if electric flux changes with respect to time, that is d phi upon dt, then there is a generation of a magnetic field which is also varying magnetic field. Right? So, due to this varying magnetic field, what happens? Here, one more current generates, and that current is known as ID or displacement current. Displacement current appears. I think you are getting my point. My point is that if there is a conduction current which is varying, current, then what happens? Due to this, there is a generation of ID or ID, and that is known as displacement current. And the formula for displacement current is epsilon naught d phi E upon dt. Okay? So, according to Maxwell, what he proposed? He proposed that there is a contradiction in Ampere circuital law. It means something is missing in Ampere circuital law. And he removed that problem in Ampere circuital law by using a new concept. And that concept is known as displacement current. So, displacement current is what? Displacement current is a current which produced or which appear in a region where electric field is continuously changing. I am giving you here, look, when current or not, when electric field is changing in a region, then a new current develops. This current is called displacement current. current is called displacement current. Look here, when electric field is changing in a region, continuously changing, then a new current develops. This current is called displacement current. And this displacement current is given by ID or ID equal to epsilon naught d phi E upon dt. Why d phi E upon dt? Because there is a rate of change of flux, because electric field lines are continuously changing. And when electric field lines are continuously changing, then surely there will be a current, and that is known as displacement current. Correct? And with this displacement current we can also modify, this is one of the formula, and epsilon naught and phi, you know very well, E into A, or actually we are writing E into S, but here I am taking E into A because area I need. So it is epsilon naught A into dy by dt, and what is E? E is V upon D. V means potential, what potential we are applying, and D means the separation between the plates. So look here, it is epsilon naught A by D, and that is known as dV by dt. So epsilon naught A by D is what? It is capacity of capacitance. It means this is another formula of ID. Capacitance and rate of change of potential. So capacity C appears now in the displacement current. One question was asked in the examination, I know very well, that when a capacitor is connected with a milliammeter here, and here we have a cell or a battery. As we close the key, we find there is a deflection in the milliammeter for a fraction of second. And you know very well, capacitor always blocks DC. When capacitor blocks DC, then how it is possible there is a deflection in the milliammeter? So that deflection in the milliammeter is only due to the displacement current. When capacitor is start charging, from 0 to maximum, then there will be a change in electric field and there is a change in magnetic flux, and resultant, what's the resultant? डिस्प्लेसमेंट करंट, इसलिए डिफ्लेक्शन आता है इसके अंदर. ये क्वेश्चन आया हुआ है एक बार. सो डिस्प्लेसमेंट करंट इज द रीजन ड्यू टू विच मैक्सवेल फाउंड that now what he has to be clear up in the Ampere circuital law using displacement current. So according to Maxwell's Ampere's modified equation, Maxwell's Ampere's displacement law, this is, maybe writing is not good, तो आपको मेरी आवाज़ तो सही आ ही रही होगी. जस्ट चेक इट हियर. एंड मैक्सवेल्स एम्पियर्स डिस्प्लेसमेंट लॉ, दिस इज मॉडिफाइड लॉ, एंड दिस इज एक्चुअली फर्स्ट इक्वेशन, बिकॉज मैक्सवेल प्रूव्स एवरीथिंग यूजिंग हिज मैथमेटिकल इक्वेशंस, theoretically only. And the first you know very well that B vector dot dl vector equal to mu naught. Yes, I, but it is not I here. It is I plus ID, or mu naught I plus epsilon naught d phi E upon dt. This is modified Ampere's circuital law by Maxwell. So now current ID is there. What does it mean? It means magnetic field is there where? Look here. I am going here. Here there is no magnetic field, here no current. But now you know very well, here there is a current ID, and so BQ is also there. BQ is also there, due to ID displacement current, and so he modified it. Again I am coming here 2, 3, and this is 4th, I think. Okay, so this is modified law by Maxwell. And secondly, he has given one equation of Gauss law in electrostatics, and that equation you know very well. Integration E vector dot ds vector equal to q upon epsilon naught. This is nothing but Gauss law in electrostatics. This is Gauss law in electrostatics. According to this, what's the meaning of this? कभी आपने सोचा इसका मीनिंग क्या है? इसका मीनिंग बहुत ही इंपॉर्टेंट है. मैक्सवेल has given this, that it is not equal to zero. It is not equal to zero. It means a single charge, monocharge exists and magnetic field lines are not continuous. Sorry, electric field lines are not continuous. Electric field lines does not form a closed loop. Electric field lines are discontinuous. Electric field lines are discontinuous. It means mono or single charge exist. Single charge exists and electric lines does not form a closed loop. You know very well. Electric field lines, they originate from positive charge and terminates into negative charge, but they are not coming from minus to plus again. So they are discontinuous. Then the third equation given by Maxwell was, yes, Gauss law in magnetostatics or magnetic field. So that is B vector dot ds vector is equal to 0. Very nice. That magnetic integration of magnetic field over a closed surface is always 0. It means magnetic field is continuous, and magnetic field lines forms a closed curve. You know very well, magnetic field lines are always start from north to south, and inside they move from north to south, so they form a closed curve. And these are magnetic field lines. Sometimes we are calling them magnetic lines of force. That is wrong. These are not magnetic lines of force, because here force is not parallel to the direction of the movement of magnetic field lines. It is perpendicular. In electric field, force is also in the same direction of the electric field. And so we are getting from here that monopole does not exist. So this is third equation. Then the last equation related with electromagnetic induction, Faraday laws of electromagnetic induction. And according to that, E vector dot dl vector is minus epsilon naught d phi b upon dt, or d phi e. D phi e upon dt. It is what? D phi e upon dt, but you know very well, we are not getting this, we are always what getting? D phi b upon dt. Actually that result this. But according to Faraday, If there is a rate of change of magnetic flux, then only there will be an induced EMF or induced current. Okay, so these are the four equations due to which Maxwell predicted the existence of electromagnetic waves when in 1874. But after that, 1874 Maxwell, okay, and then in 1885 to 1887, Hertz, Heinrich Hertz, you know very well, H.R. Hertz, he experimentally generate electromagnetic waves. So experimentally proof was given by Mr. Hertz. Experimentally verified. Experimentally verified EM waves. How? कैसे किया उसने? And wavelength is of 6 meter only. Wavelength is of 6 meter. If wavelength you know, you can find the frequency also, because C is equal to mu lambda. So mu is equal to C upon lambda, and C you know very well, 3 into 10 to the power 8 meter per second. थोड़ा लंबा हो रहा है पर जरूरी आपको अच्छा भी लग रहा होगा, मजा आएगा आपको. Okay, so he has taken two plates, two metal plates he has taken, highly polished. This is second plate. This is second plate, and these are connected with copper wire, and here S1 and S2 are two brass sphere, highly polished. These are highly polished zinc plate, metal plate, bड़ी bड़ी plates हैं, and these two are connected with a induction coil. These two are connected with induction coil. Induction coil you know very well. Induction coil is a device which can store a large amount of our high potential. So high potential generates here. High potential, and you know very well the dielectric strength of air is 3 into 10 to the power 6 volt per meter. Dielectric strength means up to this air is an insulator, and after this air becomes conductor. So as soon as the potential here is more than 3 into 10 to the power 6 volt per meter, now air around here ionizes and they start moving from higher potential to lower potential. So here spark develops, and this is electromagnetic wave. हर्ट्स ने कहा देखो मैंने इलेक्ट्रोमैग्नेटिक वेव प्रोड्यूस कर दी, बट यू नो वेरी वेल अदर साइंटिस्ट दे लाफ, अरे हर्ट्स कहाँ है, क्या इलेक्ट्रोमैग्नेटिक वेव है? इफ दिस इज एन इलेक्ट्रोमैग्नेटिक वेव इट विल प्रोपेगेट इन द एयर ऑल्सो, तो हमें पकड़ के दिखाओ. हर्ट्स बोला बिल्कुल बताएंगे, बिकॉज एक्चुअली दिस इज व्हाट, दिस इज ट्रांसमीटर, दिस इज ट्रांसमीटर. एंड नाउ कुछ भी नहीं किया उसने, he has taken here a copper wire, copper loop, ये भी कॉपर का है, बच्चों बताया था आपको. एंड दिस इज ब्रास. ये एक्चुअली दिस इज जस्ट बिहेविंग एज ए कैपेसिटर. अरे कैपेसिटर मीन्स एलसी सर्किट, दिस इज एन एलसी सर्किट ओनली. ओके, सो हियर अगेन ही कनेक्टेड टू वेरी स्मॉल spheres S1 dash and S2 dash. These are made up of brass again. Okay, now he starts moving this, ऐसे मूव करना शुरू करती है, and he found that spark developed here, and spark is maximum when it is perpendicular to this. उसने बताया देखो ये spark develop हो गया ना, here there is no cell, spark is here, so electromagnetic wave generates here and I receive here. This is known as Hertz oscillator. is known as Hertz oscillator. So this is the experimental proof of electromagnetic waves, my dear students. And after that, what happens? Surely another person will come, and that person, Mr. J.C. Bose, in 1895, Mr. J.C. Bose of Calcutta, our India, he generate electromagnetic waves, but only in laboratory, 5 to 25 millimeter. But he got nothing, क्योंकि laboratory में किया था, and it was only in laboratory itself. Outside किसी ने देखा ही नहीं, पता ही नहीं लगा. And then from 1895 to 1899, Mr. J.F. Marconi of Italy, he actually performed the same experiment, and then he established first wireless communication. He established first wireless communication across English Channel. Across English Channel. चैनल मतलब टीवी चैनल नहीं, अरे पानी से बहने वाली धारा. कितने किलोमीटर? 50 किलोमीटर. It means here there is a transmitter and here there is a receiver. One question maybe comes in your mind, यार हर्ट्ज ने भी तो ये किया था, तो फिर उसने इतनी दूर वेव क्यों नहीं भेज दी? You know very well, the wavelength for hertz is 6 meter. So frequency is very less. Frequency means energy. If your energy is less, you cannot travel far. So you have to reduce wavelength. If you reduce wavelength, just like here 5 to 25, the same here. Frequency increases. What increases? Frequency increases and it can travel far, 50 kilometer. And then Marconi was known as father of wireless communication. क्या कहा इसको? Father of wireless communication. And he got, बच्चों नोबेल प्राइज भी मिला भाई उसको. He got Nobel Prize. So this is the history. But after that, you know very well, number of electromagnetic waves they discovered by number of scientists. And then उनका एक घर बना दिया, एक परिवार, and that is known as electromagnetic spectrum. तो मुझे लगता है 3 वीडियो बनाने पड़ेंगे, एक वीडियो में काफ़ी टाइम हो गया है. Now secondly, I am going to give you what about the electromagnetic wave, कैसे हुई अब, और इलेक्ट्रोमैग्नेटिक की प्रॉपर्टीज़ क्या है. तो यहाँ ही रुकते हैं हम बच्चों. सो थैंक यू वेरी मच फॉर ज्वाइनिंग मी. एंड इफ़ यू लाइक दिस वीडियो, काइंडली राइट ऑल्सो, ऑलवेज राइट इन द कॉपी, शेयर इट, कमेंट जरूर करें आप, एंड प्लीज़ लाइक इट ऑल्सो. थैंक यू वेरी मच. थैंक यू.